Hello.
Hello, hello.
How
How
are
you
you?
doing? Doing good. How are you?
I am good.
Wonderful. All right, we're still waiting on Clinton.
Okay.
I know that Desmond, she actually wasn't able to meet today, so
Okay.
it's just gonna be us three. That's for sure.
I'm just getting logged on.
Yep, not a problem. I'm doing the same. All right, I'm gonna try inviting him again. Just a sec. Oh, there we go. What's up, guys?
Tablet.
All right.
It's recorded.
All
I'm
right.
gonna because there's a lot of people talking.
Yeah, not a problem, man. You go ahead. No worries. All right. Well, I was actually able to, for this one, I was able to kind of study basically the hold up, I guess the information for lesson 3. But I guess were you guys able to do basically the preparation assignment? The probability, discrete random variables?
Yes, I was.
Nice. Good job. Actually, I attempted to do it, but I didn't finish it all.
Okay.
But I guess if you guys would like to, we could either basically talk about that or we could just go straight to the quiz. What would you guys like to do?
If the quiz is too long, my Tuesdays are my days that I have a 6 o'clock meeting. We can start with if it's 6 o'clock and I'll have to take off another meeting.
Sure. Yeah, I guess. So you're saying that we could just start the quiz, right? Because you have something at 6, right?
Yeah, we could do either way. If we want to discuss the preparation, that's fine too. We just at 6 o'clock. But on Thursdays, we're on with we have an hour and a half.
Yeah, man, that's not a problem at all. I guess one thing we can do, if you guys want to, I guess we could kind of briefly talk about basically the homework that was there. I guess we can start off. What was the notation is used to denote the probability of an event occurring? So Wendy, were you able to get that one?
Yeah, it's P and then in parentheses X.
Awesome. Way cool. That's awesome. And then I guess please state and describe the 3 rules of probability. So basically, I was able to get that one. So the 3 rules for probability, if you actually look at your homework assignment, your the textbook that we're using, which is basically the Statistics by BYU Math. So the rules are the probability of an event is X is the number between 0 and 1. And then rule 2 is if you list all the outcomes of an experiment, such as rolling a die, the probability of one of these outcomes will occur is 1. In other words, the sum of the possibilities of all the possible outcomes of any experiment is 1. So that would be basically that one. And then the third one is the probability that an event X will not occur is minus the probability that will occur. All right. So what does it mean to be random? So I guess that's kind of basic. So I'm pretty sure everybody, all of us kind of understand that one. And then it says, what does the phrase discrete random variable mean? And I actually was not able to get that one. What did you get that for that one, Wendy?
You know what? I skipped that.
Well, all right. No worries.
I did print off the answer. Let's look at that. Okay. 4. It says discrete random variability is sometimes the various following a specific pattern or over a long period of time.
Nice. Okay.
I think it just means it's just random.
Well, perfect. Wonderful.
Figure it out.
So I guess number 5, it says an 8-sided die has 8 possible outcomes for each roll. 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling the a number greater than 5. So a number greater than 5.
So I put 3 8s, which would have been 6, 7, and 8. So 3 items divided by the 8.
Yep,
So it would be
that makes sense.
47.5.
2, 3, yeah, that makes sense. So it'd be 3 divided by 8, and then you'd get basically the decimal, or yep, that makes sense. Wonderful. All right, way cool. And it says calculate the probability of getting a number calculate the probability of not getting a number greater than 5. So not getting a number greater than 5. So it'd be just basically the opposite, right? So just basically be 1, 2, 3, 4, 5. So it'd just be 5 divided by 8. And that would give us 5/8, or decimal 0.625. I guess that makes sense. Well, I guess that was a review. We're good. All right. Well, I guess we can actually start the test now. So I will pull it up right now. All right, I am good to go. Are you guys there now? Yeah, the group quiz, yeah.
You said test. I was like, didn't mark anything.
Sorry, bud. Yeah, not test, but quiz.
Okay, yeah.
I'd be surprised too, that's for sure. All right, so I guess we can actually start off with question 1 and 2 are just kind of saying that you participated in the group's meeting, so we're there. Preparation of the assignment, attended to the group, so we can answer that question.
You can mark false for extra points.
What was that?
You mark false for
could you repeat that one more time? No. Oh, sorry, man.
If you mark false for gold, you get extra credit.
Yeah, that's right. Man, I wish, man.
Where's the other person? I can't remember her name. Lucy?
Yeah, so there was you mean the other girl that was supposed to be here? Yeah, she basically, what happened is that she had another group meeting, so she wasn't able to meet today.
Oh, okay.
Yeah. Yeah, man. So it's just us.
All right.
All right. So I guess we can start off with question number 3. So the information says, use the following information to answer the next 3 problems. Human blood can be classified into one or basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and proportions given the table above define the probability distribution. What do you guys think?
I think it does.
Yeah, I believe it does too. Because I think it has all of the percentages right there, so it definitely does. What do you think, Wendy?
I think so. If it adds up to 100 or
Yep.
1. Yep,
Yeah, it
we're good.
does. Legit. All right, we are good with the true. All right. So number 4? What is the probability that a randomly selected person in the United States has type O blood? So I guess if we look at the chart, type O says 0.45. So I believe that would be the answer.
Question.
Yep.
Should we list it as 0.45 or just 0.45? What do you guys think?
Sorry, man. Can you hold up? I'm gonna grab my headphones. Maybe I'll be able to hear a little bit better. I'll be right back. All right. All right, my friend, go for it.
Hey, so my question is, are we supposed to type it as 0.45 or with 0.45?
Oh yeah, for percentage. I think. Actually, let's check that out. Let's see. Information. Do we have the quiz group? Give over. Oh, there we go. If you actually look just right above right there, just right above the 2 first questions, in the information. Yeah, so I think we're just putting it in decimal form. I think, for example, do not give probability answers as percents. Okay, so I guess that's actually good to know. Right. So I guess we just use decimals.
Okay.
All right, so I believe it just would be, question 4 would be 0.45, just because in the graph it's stating for it to that O, so I believe it would be that answer. Everybody good on that? Yep, awesome. All right, we'll move on to question number 5. Would you take that away there, Clinton?
Yeah. What is the probability that a randomly selected person will not have type O?
All right, the probability that a person would not have type O blood. So I
think it's 0.55. So it's the sum of the other 3.
Yeah, that makes sense. Yep. All right, we're good with that one. I think this one's actually kind of straightforward rather than the other ones. Legit. All right. Wonderful. Okay, the next question. Alice, would you like to read the next one?
Yeah. Carolyn Rose and her colleagues conducted a study in which dogs were training to detect bladder cancer. The dogs were trained to lay down next to a specimen derived from the bladder cancer patient. Tangle, one of the dogs, demonstrated the identification of the specimen. Several bowls contained urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from one person identified as bladder cancer patient. If the dogs guessed a random, what is the probability that they were correct? identifying the dish containing the specimen from the bladder cancer patient.
All right. So I believe from the question, I think it would be 1 divided by 7. For basically because there's 7 dogs, right? I mean, there's 7 7 balls.
Specimens, yeah.
Yeah, so I think it would be, and each dog is basically testing them, so I think it would be 1 divided by 7. Then I believe the decimal, as it says, round the answer to 3 decimals. Let's see that. 1 divided by 7.
1.14.
Yep, that's what I got too. There you go. All right. Question number 7. I'll read this one. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. This is little evidence that dogs can detect bladder cancer. So I think since the combined total of 40, so I think it would be 22 divided by 54, because they did it a total of 54 trials, and it came, and then the specimen, so they were able to recognize cancer patients 22 times. So I think it'd be 22 divided by 54. So that means that they would get 40%. So go for it.
I'm thinking that if you could do 4 times, isn't 22% more than 50%? I mean, 22 times more than 50%? No, it is 40%.
Oh, you mean, how much would it, you would think that 22 divided by 54 would be more than 40%.
No. Anyway, you're
well, no worries, man. Hey, I could very well have messed up, man. Sometimes I overread questions, so I was just like, sometimes I just analyze them differently. But hey, if everybody's good with that, man, I'm down. Does everybody believe that question is right? I believe that it would be the second one. There's little evidence that dogs can detect bladder cancer. Just because I think it's 40%. So if it wasn't 50%, if it was 50%, it could be 50-50, right? If it was 60, it'd be better. But since it's only 40%, I think that there is little evidence that dogs can detect bladder cancer. What do you guys think?
Sounds good to me.
All right. Sounds good. Sweet. All right. So who would like to read the next one? Awesome.
Yeah, you're following into the next 2 questions. M&Ms are small chocolate candy. The M&M's website indicated that in the United States, the distribution of a bag of plain M&Ms is given in the following case. If you reach into a bag of plain M&Ms, the probability of flying a red colored candy. Pretty simple. 0.15.
Yep, that'd be it, man. Straight up. All right. And then the next question, it just states, what is the probability that a randomly selected candy is green? All right. So as we look at the graph, it shows that green is not there. So I think what we would do is that we would add up all the different colors for M&Ms, and that should give us a number. So it'd be 13 plus 0.13 plus 0.14 plus 0.13 plus 0.24 plus 0.20. So that would get us 84. And then I believe we would do 0 point. So we would do 1 take away 0.84. 0.84, which would give us 16. So I
0.84 gives me 13.
Oh, it gives you 13? Yeah, okay, maybe I messed up.
I got 16.
You got 16? Okay. 0.13, 0.24 plus 0.20. Okay, 84. So one takeaway. 84. Yep, I got 16 again.
Okay.
Did you get the same one, my man?
Yeah. Wait. We did adding and subtracted. Would you subtract?
Oh, so yeah. So I subtracted it by. So I calculated basically all the colors. So brown, yellow, red, blue, and orange, and that gave me 80. So 0.84. So what I did is that if you calculate, so 1 in a percentage, if you do 1 times by 100, it would equal 100%. So what I did is that I did 1 takeaway 0.84, and that got me 0.16.
Okay. Okay.
Bueno. Oh, did you get it, my man?
Yeah.
Awesome. No worries, man. I have another math class, and man, I punch in things wrong all the time. Then I look at the answer, I'm just like, yep, I got wrong, legit. All right. And then it says, question number 10. Would you like to read that one,
Sure.
Wendy?
Sure. The probability that a random licensed candy, hello, is not green.
All right.
Oh, that was straight up good.
Yeah, it's 0.84 because we calculated that beforehand, right?
Yep.
Awesome. All right. So the next question. Would you want to do that one, Clinton?
Yeah, I can do that.
Awesome.
Yeah, use the following information to answer the next question. The ACT score of students admitted to a medium-sized public university in the Western United States were taken from epics.com to summary statistics for calculated. Half of the observations are less than or equal to what number? I would say it's less than or equal to the median.
It would be, yeah, I believe you're right. Yeah, it says half of the distribution. Yeah, I think it would be 24. I believe it would be that. All right.
Kind of like middle.
Yeah, because I think, and then, yeah, because it's 50%. I think that'd be the 50 percentile also in a graph, I believe.
Okay.
All right, the next one. Based on the information in the table above, the top 25% of the students scored above what number? So if they said the top 25%, and I believe, if I'm wrong, I mean, tell me if I'm wrong, but I believe that it would be Q1 because Q1 is actually, in the graph, I believe it's the 25th percentile, which is 25%. Does anybody agree with that? I'm not completely sure, but because I believe that if you look at the graph right there, you have the medium, which is 14. You have Q1, which is, I'm sorry, so you have the medium, which is basically 0, so it's like at 0%, right? And then Q1 is 25%. Medium, was that?
Sorry, go ahead.
No problem. So I think that medium would be basically 50%, and then the Q3 would be 75 percentile, and then maximum would be 100 percentile. So I believe it would be Q1. But I'm actually not completely sure about this answer. I could be wrong. But what do you guys think?
The way I was thinking was the median was 0, and Q1 would be -1 or -2 to about 25%. And Q3 would be the positive side of the graph.
That very well could be.
If you look at it as a graph, like an X and Y axis, if your median is 0, then the Q1 can be underneath it, and the Q3 is going to be about the side 25. So the top 25.
So you're saying that I guess the top 25 would be the median? Is that?
No, Q2 would be the top 25.
Oh, okay, the top 25. Okay.
Because if median is the 0 point, then about that would be the next three would be the next number.
Hey, you very well could be right. I'm actually not. I'm not completely sure about that question.
That makes sense to me on that one where it being the top 25%.
Let me see if I can draw. You can see this.
Oh, hold up. All right. Can you see? I'll have to stop talking. That's my bad.
If the median is 0 point in the axis, then Q1 is the negative 25%.
Okay. Yep, that makes sense.
Just
All right. Well, then we.
I would say 27, but
No, you could. I think you could be right, man. So, what do you guys? What is our? So, what should we do? Do we everybody think it's 27?
I think it's 27.
You think it's 27? Okay. All right. I guess that will be it. All right.
Tiebreaker, I guess.
That's right. All right. So, question 13: which of the following statements is not one of the three rules of probability? Probability that an outcome will not occur is minus the probability that it will occur. Probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of the probabilities is any probability is 1. Wow. All right. That's a lot of probabilities. There's yep. So which one would it be?
I'm leaning to the third one.
Sure,
But
yeah.
the last one doesn't. I don't like the word any in there. Because if it's not balanced on or unbalanced, it'll equal not just one.
Yeah.
This sounds so weird to me this week. So I don't know if it sounds weird to you guys.
No, it definitely does. I think it sounds weird to me. I think it would be number 3. If the probability is high, then the probability is positive. If the yeah, I definitely think it would be that one.
Yeah.
What do you? All right, I guess that's it. I mean, I know that our professor, he kind of told us kind of to submit this all by ourselves. So I believe that is our. I think that's our session. What do you guys think?
Yeah.
All right. I just don't want to get in trouble.
No, you're good.
All right. But if you guys have any other questions regarding anything,
just letting you know.
What was that?
We were wrong on. I don't know if you guys submitted it.
Oh. Okay.
I think I'll go back and look too. Good thing we have 2 choices. That one.
Yeah, I submitted it. Less than 7. And Monster 7's wrong.
Oh wow. I see.
Yeah, it's 40%, but I don't know how.
All right. Well, there, guys. I guess I will, for now, end this to a close, but it has been great.
Okay, for our meeting on Thursday, I cannot meet Thursday. Is there any way that you guys can meet tomorrow?
Tomorrow.
I'm working.
You're working.
Yeah, I'm not too sure about me for me to pour. Is there any time later on Thursday that would work for you?
I'm going to St. George. It's like 5 hours away from me. So I'll just be in a car and not have Wi-Fi.
Oh, dang.
So you guys have your meeting, and I'll just contact another group and just maybe jump in their group, or I'll just miss the points. I don't know what I'll do. But I'll figure it out. It's all good.
No worries. I mean, yeah, I'm pretty sure that it'll work out for you. You could probably jump in another one. Yeah, for sure. But it's great to have you, though.
All right. We'll see you next week.
Hey, take care, guys. You guys have a wonderful night.
Yeah.
Bye-bye.
Peace.